End curses is next, so let's start by extracting the package and configure. Compile it. And that's done. So it says the package has got a test suite, but it can only be run after the package has been installed. The test reside in test directory. See the README file for in that directory for further details. So we will run a few of them. They're just like tiny little tools that you run to see things happening. The installation of this package will overwrite libncurses w.so65 in place. It may crash the shell process, which is using code and data from the library file. Install the package with dest and replace the library file correctly using install command. The header curses H is also edited to ensure the wide character ABI to be used. Should be is to be used probably, as what we've done. Yeah, the English on that is a bit clumsy to say the least. So make dester install, remove the library, do a sed, and then copy everything we've installed at dester to its final place. Many applications still expect the linker to be able to find a non-wide character ncurses libraries, trick the application into linking with wide character libraries by means of symlinks. So we do that here. And finally, make sure the old applications look for the L curses at build time are still buildable. And if desired, install the ncurses documentation. I always believe in having documentation on a system. You may go to a system you're not completely familiar with, or there might be something different about it, or it might even be a version of Linux that's got tools with different features. It's always possible, so it's always nice to have documentation lying around. So that looks like that's ncurses. What I said. So configure the build. And build it. Some documentation. Test the results by changing the ownership to the tester user and then run the tests. I just realised I forgot to run the test for ncurses, but anyway, if you go into the test directory, you'll see some programs there which you can run, and they should display things to the screen. If you want to see that in action, you'll be able to see my previous videos. Last few videos I've been running those tests on N curses. Okay, we've got no failures there, a few skips, but that's normally not a problem. Looks like those ones in particular are for 32-bit instructions possibly. So install and install some documentation by the looks of it. HTML documentation. So that's said done. PS-MISC. Looking in the area of the book where I've just clicked rather than the title. Right, so configure. Compile it. Run some tests. And look like there's no errors there. There's no errors reported at the end. So let's install that. And that's done. So now we can move on to get text. So configure it. Okay, that was quite a lengthy configure. So now let's build that. Okay, that's complete, so let's run some tests. Right, so there's no errors there at all. There was some different stages of tests, but there's no errors at the end, so that would indicate that's a complete pass. So let's install this total. I'm not sure if it's total for this section or the complete run, but as I say, there's no errors in this bit here, so it's all okay to carry on. Right, and just change the permissions on a single file, and looks like that's it. Next we've got Bison. And run a configure. Build a package. And run some tests. Okay, that's complete. There's quite a few tests there now, over 700, nearly 800 in fact. But they're all successful ones that are run, and just 64 skips. Notice a lot of them are Java, or rather than Java language, which is obviously not installed. So that's all okay. Let's install it, and that's done. And next we've got grep. So first we remove a warning and configure. Compile it, and run some tests. Okay, there's no failures there, so let's install, and it's done. Move on to bash. Prepare for compilation. Okay, let's build it. Okay, and now we'll run some tests which have to be run as the normal user called tester. And as it says here, we need to run this as a non-root user that owns a terminal connected to standard input. So we copy this, effectively one command, and paste that in. It says one test named run built-ins notified on some distributions with a difference, but apart from that, we'll just wait for it to complete. Okay, well, I don't think I noticed that error there, so maybe it didn't fail on this platform, on this host. Let's just look for it. I didn't know. Oh, is it here maybe? Not sure that is actually an error. Actually, it says here that the diff output prefix with a greater than and less than sign. These two look identical as far as I can see, and so do these two. So that's possibly not an error. Oh, there's the run built-ins. Yeah, so there is a difference there. 0 and 1000. So, yeah, that looks okay then. Not quite sure what this is going on about. Yeah, the number at the top's just probably an offset into the file. So I think that's successful. So let's install that and run the newly executed binary, and that's complete. Libtool. So configure. Build it and run some tests. Okay, that looks like that was a pass. There's a few expected failures, a few skips. Please report test failures. So yeah, there's 144 behaved as expected, 32 were skipped, and there's another last little bit here, which was successful as well. So let's install and remove a useless static library and tidy up. Next we've got GDBM. Configure. Make. Test results. And yeah, that's all 34 tests were successful. So that's good. And install it. That's okay. Next we've got gperf. Configure. Build. Test on one thread. It says a known to fail on multiple, if running multiple simultaneous tests. So that looks okay. There's no errors issued there. And install, and that's done. Next we've got expat. Configure. Build. Test the results. That's all okay. No errors, no failures. Install it and install some documentation. And that's expat done. init utils. So make the package build with GCC 14.1 or later. Configure. Okay, and build. And make a check. All passed. So let's install the package and move a program to the proper location. And that's done. Next we've got less. Configure. Build it. Run some tests. And we've got 14 tests with no errors, so that's okay. Make install, and that's done. So now we move on to Perl. So we've got to put these two export commands in so that Perl uses libraries that are installed on the system rather than its own copies. Copy this to configure it, and as it says there, you can remove the -des to handpick the way the package is built, if you so wish. And let's now build it. So that's built. Now let's run the tests with this command. Right, so we've got all files successful, it says, so that's good. That's 1.2 million tests it ran according to that, which is a substantial amount. So let's now install. And unset these variables that are set at the beginning and tidy up. So next we've got a Perl module XML parser, which is, as you can see, capital XML. Let's put some commands in for tar. So prepare it for compilation with that command. Build it and test it. That's okay. So now we can install it, and that's done. Intel tool next. Fix the warnings issued with later versions of Perl. Configure. Build it. Check the results. One test, one pass. So that's good. Install. And install some documentation, I think that is. So next we've got autoconf. So configure. So what's it say here? You're about to use an experimental version of autoconf. Auto test parallels. Test suite support still work in progress. Okay, so despite that, there doesn't seem to be any mention of that in the instructions, so I assume it's okay as far as the LFS way of doing things is concerned. So let's just run make check. Yeah, it is running parallel because the test numbers are out of order. So let's see what happens. Not expecting anything unusual because there's no mention of anything unusual happening in the book. So we'll just wait for this to complete. Okay, so we've got all the tests that weren't skipped behaved as expected. So that's good. We can install the package, and that's auto-conf done. So next we've got auto make. Let's configure that. And build it. And use 4 parallel job speeds. Using 4 parallel jobs speeds up the tests, even on systems with fewer logical cores due to internal delays in individual tests. The test results use this. So looks like this is saying precisely that from what I can see from that. So let's run this now. So it says replace. I presume that's nproc in that. Let's get the sysguard up. There's a sysguard system monitor. That's it. Let's see what that shows us. Yeah, we've got all 4 cores, nearly all 4 being used. Certainly not being maxed out, but we have got 4 in use. Okay, so that has completed. We've got no failures. There's a few skipped, but the important thing is that there's no failures. So let's now install that, and that's done. And then move on to Open SSL. So prepare for compilation. Okay, let's build. Okay, that's done. So now let's run the tests. This is one that is known to fail if the kernel hasn't got specific settings. So we'll see how that happens, or how that turns out at the end. Right, so that has finished with result of pass, so that's good. We didn't get this potential problem here, so obviously the kernel's been configured to provide those options, or that functionality rather. So install the package. add the version to the documentation directory name to be consistent with other packages. So let's rename that and copy some additional documentation. And there's some information there about upgrading, which we're not interested in, so let's tidy that up and move on to libelf, which is in elf utils. So need to extract elf utils, run the configure, compile it, and that's built. So let's run some tests. So everything's passed. Well, there's no fails. There's some skips, but there's no fails. And now we only install the libelf. And a package config file and remove a static file by the looks of it, static library. So tidy that up and move on to libffi. It says it builds with specific optimizations for the processor in use and tells you there how to override it if necessary. So let's build that, run some tests. Okay, so that has finished testing. There's no errors, so that's fine. Let's make install, and that's finished. So Python next, and if you recall from earlier, it's the tar file with the capital P Python. So let's configure this. And build it. Okay, that's finished. Doesn't look like there's any problems there. So let's test that now with this command. Okay, those tests are finished. Let's have a look. Success, so there's no failures. Some were skipped for various reasons, but apart from that, that's a successful run of tests. Some information about installing Python 3 programs. After we boot into the LFS system and set up a network connection, a different warning will be issued. And you can suppress the warnings by running the following command, which creates a configuration file. So let's do that now. Again, it reiterates the fact that pip3 is used to build and install modules, and some other information about downgrading a module if necessary. So if desired, install pre-formatted documentation. Let's do that. So this is the other Python file with the lowercase p, and that's done. So again, remember to remove the Python directory with the uppercase p. If you use the lowercase, you'll be deleting that tarball that we've just installed the documentation with. So next we've got flipped core. Oh, have I left the glibc there? No, don't know why that happened. Oh, because I typed the G by accident. So build the package and install it. And that's all there is to that. Wheel next. Build it and install it. Next we've got setup tools. And again, pip3 command to build it and to install it. And that's done. Ninja next. So it says when run, Ninja normally utilizes the greatest possible number of processors in parallel. By default, this is the number of cores on the system plus 2. This may overheat the CPU or make the system run out of memory. So using the optional procedure below allows the user to limit the number of parallel processors via the environment, or for example, setting that. So let's do that now. We'll limit Ninja to 4 parallel processes. So if desired, make Ninja recognize the environment variable Ninja jobs by running the stream editor. So let's do that. So we've got that set now. So if we do run anything with Ninja, it will recognize that while we're in this environment. And obviously, if you want to make that permanent, you'd have to add that to the startup files of the user. Okay, it's done. It says test can't be run because it requires CMake, which is part of Beyond Linux from scratch. So let's just go ahead and install. And that's done. And now we move on to Meson. And again, it says test suite requires some packages outside the scope of Linux from scratch. So I'll just install the package. So I've got a long command here. Goes over the edge of the page. So let's just scroll right. Just check that is the end. Yeah. And that's done. Kmod next. So make a separate build directory and we use Meson to build this package or prepare it for compilation, and then we actually use Ninja so that environment variable we set to limit 4 cores will be being used now. And finally Ninja install, and that's done. Core utils. Need a patch. Then we run some commands to prepare it for compilation. And run the configure. Okay, now let's build it. Now we run some tests as root. So that's all okay, no failures. So it looks like we add. Certain tests require a user to be a member of more than one group, so we're adding tester to the dummy group here. So it's part of the tester group and the dummy group now, and then we change the ownership of the files and run the tests. Okay, so that's finished. We've got no failures again. So let's delete that dummy group and install the packages, or rather the package. And move some programs around to adhere to the FHS, the file hierarchy standard. And that's done. Now we move on to check. Configure. Build it. And run some tests. Right, so that's done, there's no failures, so let's now install the package, and that's complete. Diffutils next. Oh, what happened there? Oh, it didn't keep the highlight. Okay, now we can build the package. And run some tests. And we've got no failures there, so we can install the package and tidy up. And move on to Gawk. Ensure some unneeded files are not installed. And configure. And compile it. So now run some tests as the tester user. And that says all tests passed, so we'll remove a binary here. I'm not sure if that's from the temporary tools or not, I'm not sure. But we installed anyway, as it says here. The building system will not recreate the hard link if it already exists. Oh, I see. So it's removing a hard link so that a new hard link is installed, pointing to the new binary, I imagine. The installation process already created org as a symlink, created its main page as a symlink as well. And if desired, install the documentation. So let's do that, and that's Gawk done. So now we've got find utils. configure the package. And build it. And run some tests as the tester, non-privileged user. So no failures there. Let's now do the install, and that's complete. So move on to Groff next. So the first command, we need to specify a page size, so it's whatever's standard in your location. For the UK and I guess most of Europe it's A4. Elsewhere letter may be more appropriate. And as it says there, you can override it later anyway by adding that string to the etc paper size file. So we'll just build that now. And now we'll run make check. And had no failures there. There's 2 expected failures, but that's not a problem. Make install, and that's done. So now to grub. If your system is UEFI support and you wish to boot LFS with UEFI, well basically you need to have booted with a UEFI boot, and you need to go to the BLFS page if you want to follow that. Next thing, unset any environment variables which may affect the build. Well, I've not knowingly set any. As I said, I tend to build Linux from scratch without any enhancements or optimizations. Oh right, okay, I don't know if it's a short way of actually echoing all of these or not. I guess we'll do another curly brace work. No, it wouldn't. So I'll just run this to be sure. I can guarantee that if you do have anything set, virtually 100% that grub won't. It may compile correctly, but it won't boot correctly. I have made that mistake before. I think only once I've unknowingly had C flags and CXX flags set, and grub was actually booted correctly. Other times I've had them set and wonder why grub hasn't booted and think it's something wrong with the package or something, but it's definitely something that you shouldn't have enabled. Add file missing from the release tarball. So let's add that in. Oh, right, let's extract. So let's do that again and prepare it for compilation. Yeah, what you'll find if you do have any optimizations is that you'll probably get the grub message come up saying, I can't remember what it says now, booting grub or whatever, if you're lucky, and it will just hang there. It won't do anything else. Okay, so let's now run the compile. Right, so that's finished building. So it says about tests. You can run make check, but a lot of the tests depend on packages that are not available in Linux from scratch, so it's probably a bit pointless running them. So let's do the install and move the bash completion file to a recommended location, and then we actually make the system bootable with grub later on in the build. So let's tidy that up. Move on to gzip. Compile the package, configure the package first for compilation. Now let's build it and run some tests. Okay, that's completed, no failures. So let's now install, and that's done. And we move on to IP route 2. So we just do a little fix here because Barclay DB is not installed with Linux from scratch. Compile the package. And install it as the test suite doesn't work, and install some documentation, and that's done. Keyboard next, KBD. So we've got a patch to fix the backspace and delete keys behaving correctly on i386 key maps, and we remove a redundant program. Together with its man page, and then configure the package for building. And then build it. Run some tests. 36 tests were successful, 4 tests were skipped, so that looks all okay. Make install. And copy some documentation, and that's done. So lib pipeline. So we do configure. Build. Run some tests. That's all okay. So install, and that's done. On to make. Configure for compilation. Build the package. And run some tests as the unprivileged user. So no failures, it says. That's good. Let's install and let's make finished. Patch. Configure. Build the package. And run some tests. All okay, no failures. And install. So we move on to tar. Prepare it for compilation with that command. Now let's compile it. And run some tests. It does say that one may fail again depending on how the kernel is configured. Okay, so we did get that one failure. I highlighted it there as soon as I saw it. Binary restore. So apart from that, everything else ran okay. So I think we can install the package and some documentation. Move on to text info. So let's configure. Compile. And run some tests. That's all done, and there's no errors, so we can assume that everything else has passed these individual sections. So let's just do the make install, and there's an optional installation here to install components belonging to a text installation. The info documentation system uses a plain text file to hold its list of menu entries. Okay, so this file, if it ever gets out of sync, we can run these optional tasks to bring it back into sync. So that's text info. So now we're going to use, compile Vim. There are other alternatives that are in Beyond Linux from scratch. If you wish to or prefer to use one of those. So first we're going to change the default location of one of the config files. Prepare Vim for compilation. And build package. Okay, so now we're going to run some tests, change the ownership of the source directory to tester, make a change to exclude some tests that need curl or wget, and then run the tests, and they redirect the results to vimtest.log, the looks of it. Yep, I do. So let's run that. So there won't be anything put out to the screen while this runs, but at the end all we need to do is to check that, as it says there, the words all done appear. Okay, so that's done. So we should be able to use grep now to look for the words or the string all done in Vim test log, and there it is, it's repeated out. So we can see that that was successful. You could look at Vim test log. Oh, of course we haven't installed it yet, so you can't look at it. But you could do tail, I imagine, Vim test log, and you can see that there's none failed there. Can't actually see all done there. Which is interesting. Let's have a look at the last 100 lines. Okay, so it doesn't actually appear. Oh, it just says in the log file. Oh, I misunderstood that. Maybe it once said it would appear at the end. Now it doesn't. But anyway, the fact that we've got all done, as it says, that's fine. So now let's do make install. Create a link to Vim called vi, and change some other files as well. Some man pages. Install documentation in a versioned directory, and configure Vim. And you can get more information about the options with that command there. Actually, one thing I'll add to that, because I find it useful, is if we do say vi let's look at one of these. Oh, I was going to say, it looks like it's defaulted with this ruler I have on. But it looks like it defaults to that now anyway. I'll add that in. See if it does actually add in any other. No, it hasn't changed anything, so maybe that's just a default setting now. Right, okay, so that's Vim. Let's move on to markup safe. Compile it and install it. Next we've got Ginger 2. So again, we just compile it and install it. So now we're going to install udevd from systemd. 257. So we don't want the man pages, it's the 257 tarball. Remove two unneeded groups, render an SGX. remove one UDEV rule, adjust hard-coded paths, and prepare UDEV for compilation. Oops. And run the right. This mouse center button seems to have fits and starts about whether it's going to work or not, and when it does, it tends to double click. Okay, get the list of shipped UDEV helpers and save it into an environment variable. Exporting it is not strictly necessary, but it makes building as a regular user or using Package Manager easier. Only build the components needed for UDEV. Okay, now install the package. So we've got lots of install commands here. Again, I'm going to install, copy and paste these one at a time, just to make sure there's no errors. Just each time I copy and paste one of these, I'm just checking the outputs, see if there's anything that looks out of place. Right, that's better. And obviously making sure that what I enter in the terminal is correct. So install some custom rules and support files useful in an LFS environment. Okay, install some man pages. Unset the UDEV helpers variable and move on to configuring. So do this UDEV HWDB update to create an initial database, and that's that. So mandb prepare for the compilation. And build the package. And run some tests. So there's no errors at the end, so I must have had passes all the way. So let's now install. And there's non-Englishman pages in LFS, there's some information there. And that's it. Proc PSNG. Okay, it's configured, let's build it. Run test as the tester. User. Okay, so it says one test name PS with output flag, BSD time, etc. is known to fail if that option is not set in the kernel. So obviously it is because we haven't got any errors. So that's fine. Let's install. And that's done. Util Linux next. Thanks. So quite a hefty configure command here to prepare for the compilation. And we'll run make to compile the package. So that's built. It says running tests as root can be harmful to the system, and it needs a certain option set in the kernel. So I'm not going to be doing that. just run the test as the unprivileged tester user. Okay, so that's all passed, all 313 tests passed, that's good. Let's now install the package. And move on to E2FS progs. So once again we create a temporary build directory and change into it. Prepare for the build. And compile it. So that's done. Let's run some tests, and once again it does say that there's a chance that a couple of tests may fail. Well, we're using ext4, so we don't expect this one to fail, but this other one it says is known to fail. So let's see how it goes. Okay, so yes, we've got one failure, assume storage pre-zeroed, which is the one that's mentioned here. So everything else is okay. We can go ahead and install. Remove some static libraries that are useless, and we need to update an info file by the looks of it. And create some additional documentation. Configuring E2FS progs contains default values. This configuration file for various command line options. You may edit the file. Some utilities which aren't in LFS or BLFS cannot recognize an ext4 file system with metadata csum seed feature. So as far as I know, don't need that, because if I was to do a BLFS, very unlikely there's anything else outside of that that would need that, but it's there if it needs to be changed. So I'm going to leave that as it is. Tidy that up and move on to syslog-d. Configure. Build. There's no test suite, so we just install this. Create a syslog-d or syslog-conf file. And that's it done. Sys for unit. So it's a patch done. Build straight away without any configuration. There's no test suite, so just install it. And that's complete. So that's all the packages built, and we can move on. So debugging symbols, it's basically saying here that we can reduce the size of the system by clearing out unwanted stuff. So majority of users, I imagine, wouldn't need debugging symbols. So it looks like there's approximately 1.6 megabytes. Oh, this is talking about Bash specifically. It's giving examples of how much space could be saved. And it says stripping debugging symbols usually some 50 to 80% smaller than its unstripped counterpart. So stripping the section is optional. If the intended user is not a programmer and does not plan to do any debugging of system software, the system size can be decreased by some 2 gigabytes by removing the symbols, debugging symbols. It says most people who use the commands mentioned below do not experience difficulties. I have once or twice, and it just completely trashes all the work you've done. So it says it's a good idea to make a backup of LFS in its current state. Basically, it will overwrite the binary or library file it's processing. This can crash processes using code or data of the file. If the process running strip is affected, the binary or library being stripped can be destroyed. This can make the system completely unusable. To avoid this problem, we copy some libraries and binaries into temp, strip them there, and then reinstall them with the install command. So what I'm going to do, I will back this up because I'm going to strip this, and I don't want to risk trashing anything. There's no commands here demonstrating how to do that, so I'll show that to you as far as I can. The only thing is the only external drive I've got to hand is a USB 2, so it's going to be a little bit slow backing it up, but it should still work. So I'm just going to plug that in now. So I may see a pop-up on the screen when I turn it on. I'll see if I can arrange this so I don't trip over the wire. Okay, so I'll turn this on now. And what I'm going to have to do the backup, I'm going to take a full disk image, I think, which is why it's going to take a little bit long. So it'll be a full image of the hard disk rather than just backing up all the directories. Or shall I? I might actually, let me think what would be best. Let's see what that came up as. So that device is SDC, okay. Right, so what I'm going to have to do is to come out of the root environment, and then I'm going to have to unmount all of the virtual file systems that are mounted and also what's at LFS. So if I echo LFS, if I do umount -r $LFS, that should recursively unmount everything. And you can see that the last mount there is this portal on run user. So there's nothing mounted at LFS. And in fact, if I do ls-l a at that mount point, you can see it's completely empty. Let's just remount that /dev/sta3. Yeah, I will image the whole disk because it takes all the partition configuration as well. I won't have to set that up. So it is going to take a little bit longer because it'll be archiving empty space basically. Let's see how big it is. /dev/sta3 into LFS. Yeah, it's only 4 gig, and I'm going to be backing up 230, 250 gigabytes. So it's a bit crazy, but it just makes life simpler if I do need to do a restore. I won't have to do the formatting, the partitioning, and so on. So let's unmount that again. I need to make a location for the external drive, so I'm going to mount the external drive SDC1 at MNT USB, and I'm going to use DD to take its data from /dev/sta, which is the hard disk on the laptop. I'm going to use a block size of 64K, and I'm going to show the progress of the copying, and I'm going to pipe this through gzip using the minimal compression, so I'll get some compression but at the fastest speed, and then I'm going to pipe that back through DD and output it to the external drive, which is on USB, and I'll call this LFS 12.3 256 gigabyte, and it's the SDA, and it's the disk image, and it's a gzip file. So, and I'll time that. I'm not sure how long this will take. I guess it's going to take between half an hour and an hour to do, considering it's got a quarter of a terabyte to get through, but it should be relatively fast. Most of the disk is going to be unwritten too, because if you remember, I cleared the disk completely. So let's get that going and wait for it to complete. Initially, you might notice it's quite slow, but it should speed up as it gets to the point where there's no data on the disk, where it's all zeros, because it will be highly compressible. It will actually speed up at that point. Like I say, the external device is a USB 2, so it's not particularly fast. So initially it might be a bit slow, but it should get faster as it goes along. The initial bit looks fast because it's probably caching that data in memory at the moment. I can't see that. Yeah, this has just started being written to now, so that'll probably drop that speed. So, yeah, wait for that to complete now. Okay, so that's done after 20 minutes. That's a little bit faster than I thought it would take. As I say, probably because most of the disk is just empty. So let's just have a quick look at that. One thing I should have maybe done, might have improved the speed slightly, is put a block size on the output, but never mind. It was a reasonable time anyway. So yeah, that's all there. It looks like it's just about 9 gigabytes, 8.5. So that's not bad for a 256 gigabyte disk. So I'm going to unmount that now. And turn that off. And then what I need to do next is to remount the LFS partition. So SDA3 on LFS, SDA1 on LFS boot. And I just realised I didn't turn the swap off, did I? No, I didn't. So that shouldn't really cause too much of a problem. If it complains that it's not being closed properly, or it's not initialized properly, it's not too much to reformat the partition. It's not like it's data that needs to be stored between reboots. It's ephemeral, so it doesn't really matter. So yeah, the next thing I need to do is to go back to the page that tells us how to load the virtual kernel file systems. So I need to mount dev again, dev PTS, proc, sys, and run, and then re-enter the root environment. So we're back to where we were in this stripping chapter. So I should be able to follow this now and hopefully not have any problems, but if I do, I've got to back up. So I'll copy this first command in, cd user lib, copy this for command in, and you can see that's doing stuff. Then this assignment here, and this one, and this for command, and this one. And this looks like it does the bulk of the stripping. Okay, so that's done. We've just got to unset the variables. It says a large number of files be flagged as errors because format's not recognised, so that's not a problem. So it looks like there hasn't been any problem there, which is good. So let's come to cleaning up. We can remove some temporary, some files in the temporary directory and any libtool archives that are left. The compiler built in chapter 6 and 7 is still partially installed and not needed anymore, so let's remove that. And finally remove the temporary tester user account, which is now not needed.